Can you share your screen?
Oh, yeah.
Okay. So, ready?
Let me pour some water first.
Okay.
Alright, I'm ready.
Okay. Um. Oh, okay. Hi. So, hey everyone. Thanks for joining us today. Sean, my question for you is, uh, so right now you have a linked list, but
Mm-hmm.
unlike normal cases, uh, you're given um you're given reference to you're given access only to a certain node in the middle of the linked list. Sorry, not the middle, but like um, by middle I mean not the first and not the last node.
Mm-hmm. Mm.
And I want you to delete that node. How would you do it?
Okay. I've done this one before.
Oh, okay.
Should I still do it?
Yeah, yeah, sure. Just
Okay.
walk me through your reasoning process then.
Given access
Mhm.
to uh, not to a middle node. And then you want to delete the node, right?
Yeah.
Okay. So the linked list, it's a singly linked list, right?
Yeah. Yes.
Alright. Let me plug in my. So you can't do it traditionally, where you delete the node and then you reattach the next node to the last node. Here we go. If you're given this one, if you want to delete it, what you do is uh, instead of instead of reattaching it, you absorb the value of the next one.
Hmm.
So the objects are the same, but the values in the objects are inherit the next one. And then when you reach the last one, you just you delete that one because the second to last one has copied the last one essentially.
Okay. Can you show me an example with actual elements with actual values?
Okay. Uh,
So it could be
so let's say we store integers
okay.
inside these values.
Mhm.
And it's guaranteed that we have the middle. We have
Yeah.
something in the middle.
Yeah, so it's not the first or the last element.
Okay. And it's not
And
null.
let's assume that you're given a proper linked.
Okay. When we get two, so when we're at this node reference,
Mm-hmm.
basically we say two we pseudo delete the 2,
Uh-huh.
so we don't really care about this 2 reference value anymore. So we
Mm-hmm.
say 2's this value is equal to the next this dot next,
Okay.
which is 3.
Mm-hmm.
And then for each value for the next nodes in the linked list, we do the same. So 3's will get 4's, 4's will get 5's. And then for each iteration in the traversal,
Mm-hmm.
in the beginning we check if that current one dot next is equal to null,
Mm-hmm.
which means that's the last one. Since we want to delete this 2 and act like 1 is pointing to 3, the last one would be a repeat. Um, so once we detect this dot next is equal to null, we actually make this so the last one, I guess you need a pointer to the last one too. Why don't we do okay, we can check for next dot next in the end of our while loop. In the next dot next is equal to null, we can do next is equal to null. So when we're at this 5 here,
Mm-hmm.
or this pseudo 4, we inherit the 5, so this becomes a 5. And then at the end of that while statement, check if is my next dot next null, and if it is, next is equal to null. So that's essentially the end. And we can do that because the last one is guaranteed. We're guaranteed to have a middle element, so we will never get the last element, which will throw us an error if we do next dot next.
Okay. What's the runtime for that?
Slug runtime is space O linear. Memory is constant.
Okay. Is that is there any way that it could be faster?
Is there any way that could be faster? We can do a runtime actually. We can do a constant runtime. If we take the next value and we make the next values x into here, so 2 will take 3's value, which is guaranteed to exist. Yes. Two would take 3, and then this equals 3's dot next. This dot next dot next. So this copies that, and now this takes the next element's next element. So that's constant runtime.
Okay. So let's see code it.
Sure. Okay. And it doesn't return anything, right?
Oh no.
Okay. Oops. So we get middle node. It's guaranteed to be a valid middle node, so we don't need error checking right now. So let's do. So we copy n dot value is equal to n dot next dot value. Just copy the node. Now we n dot next is equal to n dot next dot next. That's it. That's it. That's it, I think.
Yep, that's it.
Alright. Yeah.
All right. Good job.
Thanks.
So, one comment I have is, so I one comment I have is for linked lists, like for when you're making examples, usually it uh even if you think, oh, it's much easier to just say, generalize and say, oh, these are just nodes. It's better to make them have some sort of value.
Mm-hmm. Mm-hmm.
Um, that's pretty much it.
Cool. I'll write that down.
Same for like graphs or strings or whatever.
Yeah.
Arrays.
Yeah. I knew this was strictly like a referencing thing, so. But yeah, had I like not know the question, I probably would have drew better examples. Okay, cool. Thanks, Greg.
All right.
It's nice and short.
So, okay. Thanks, everyone.